Hi everyone, today we're going to talk about some advanced lesser known data structures in Python. So first let's start talking about heap. So we know heap as a data structure is going to help us find kth largest elements. The k can be anything, so it can be the top 3 largest elements or the top 3 smallest elements. So we have a built-in in Python called heap queue. We are going to use that and see what are the possible operations. We are going to see some code snippets which will be useful for you to understand quickly what this heap queue is capable of. So we're going to import heap queue, and by the way, I'm using a Jupyter notebook. You can use any IDE of your choice. I find this pretty easy to quickly just run a code snippet. So I'm going to initialize a list. Essentially, we'll actually be using a list, and you'll see in a minute why. Now, heap queue.heapify this list. Now this is going to become a heap. By default, heap queue provides only a min heap. Now let's print this and see what happens. As you can see, it has sorted the list, and time complexity is of log n for insertion and removal. So now let's say you want to push an element. So the possible operations, as you can see here, heap pop, which is going to pop an element, remove an element. Push is going to insert an element. So let's try pushing an element. Heap comma, I want to push 2. Now you have 2 in the right position, which is already sorted. So now let's say you want the smallest element popped out. Heap queue dot heap pop heap. I'm printing the smallest now. Running the code, and this is 1. So this is going to be very useful for you when you're tackling leak code problems. There are many more operations which you can dive into. If possible, I'll post separate videos of each of these in much more detail. Now let's move on to the next data structure, shall we? So the next data structure is actually called a counter. This is actually a dictionary, but this is especially useful when you want to calculate the frequency of, let's say, like numbers or letters in a string. So it's very useful to calculate the occurrences of a particular character or number, and this is very useful when it comes to leak code problems. So we're going to first import counter from collections, and let's say we have nums. It's a list, and I want to know what is the frequency of each of these elements, right? So what am I going to do? I'm just going to do counter of nums and print this, and you can see, so the number of 2's are 3 here, correct? And the number of 1's are 2. So similarly, each of these elements in the list are being now counted. So let's say we have a string, and I just want to know the frequency of these characters. If I print it, you beautifully get the frequency. So this is very, very useful and a very important one which many people don't know. Moving on to the next data structure, default dictionary. So default dictionary, as it says, is also a dictionary, but it is especially useful when you want to write a piece of code for missing keys. So if you're going to use a traditional dictionary, if you actually try to access a key which is not available, you're going to get a key error, correct? but in this case this is going to, if you use a default dictionary, it's going to handle itself, and this is going to reduce the amount of boilerplate code which you have to write for missing keys. So let me show you an example. So similar to counter, I'm going to import it from collections. So I'm going to initialize a default dictionary, and I'm just going to say not available. You'll see in a minute why and how this is going to work. I'm going to insert a key called existing, and I'm going to say yes. And now I'm going to try printing something which we already know doesn't exist. Okay, I'm going to try to access missing. See, it doesn't throw a key error and it simply says not available. Whereas now I'll just show you a dictionary, a normal dictionary. Okay, a normal dictionary, and if I try to access something which is not available in the normal dictionary, now this is going to throw a key error. Sorry, dx of yes. See, this got printed normally because this is a normal a default dictionary, and this is a normal dictionary where you're accessing a key which is not present, so you get a key error. So to avoid this scenario, we actually use this. And not only this is also used in the problems group anagrams. It's also used to group certain words, or you can also use it to calculate frequency. So we're now moving on to the next data structure. Something which is really useful is a double-ended queue, correct? We know what a double-ended queue is. So queues generally follow the FIFO method, which is first in and first out. So a double-ended queue facilitates us with fast insertion and deletion, and you can just import from collections, import DeQueue. So I'm gonna just create, I'm using a list here, as you can see. Okay, it just got printed, and now I'm gonna try to perform some operations on it. I'm gonna append. It got appended, and now I'm going to append left. So if you do append, it gets inserted in the last. If you do append left, it gets inserted in the front. Similarly, I just want to pop, and as you can see, the 4 is gone, but you can also pop left. So if you pop left, what happens? The 5 should go, correct? The 5 is gone. The DeQueue is actually useful in sliding window problems when it comes to lead code. So the best part is that it provides us with O of 1 time complexity, append and pop operations. And now we are going to see the last data structure of this video, but a part 2 of this video is coming up. It's called Bisect. It's basically a list which, when you try to insert elements, it inserts it in the sorted order. It's very useful, and it performs O of log n operations. It actually uses the binary search algorithm, hence the name. So I'm directly going to import Bisect. This is not in the collections module, and I'm going to have scores in a list. Say we have 4 scores. Bisect.insort, which means that it's going to insert in a sorted manner. Scores, 25, and we're going to print scores. So as you can see, 25 got correctly inserted in the sorted manner, and we can also get the position of a particular element. Yeah, so we got the index of 25. Hope you guys found this video helpful. More such videos are going to be posted in this channel. Please comment down your thoughts and let me know what you'd like to see next. And don't forget to subscribe. I'll see you guys in the next video. Bye bye.